Okay, so this is a linear DE. It's also separable. I can never spell separable. So I could solve this. I could say y prime, or let's leave it in differential form, equals negative 5y. Divide the y over. So dy over y equals negative 5t dt. And then I could just integrate both sides. So I could easily solve this as a separable DE. Let's finish it out. Natural log absolute value of y equals negative 5t squared over 2 plus c. And then I could put it in explicit form if I wanted to. So separable, like that's the first thing I look for. You give me a DE, I'm going to check and see if it's separable. They're always easier. But let's solve this as a linear DE. So we take this function in front of y, and we find our integrating factor, which is, we call that mu of x, and that's always e raised to the antiderivative of p of x, in this case, dx. So p of x in this case is just 5. So I want the antiderivative of 5 dx. Don't forget your dx. Every time you write an integral, you have to have a differential. That would be 5x. So now I want mu of x will be e to the 5x. So I'll have y prime. I'm going to multiply everybody by this, multiply everybody by the integrating factor. Okay, then the left-hand side is the full differential, the product rule derivative, I should say, of y times the integrating factor. This is a necessary step. A lot of people like to jump straight from here to the answer. And you got to show all your work. You have to write this step out. Now, we should check that. What is the product rule derivative of this? That would be derivative of the first, y prime, leave the second alone, plus leave the first alone, there's the y, times derivative of the second. Derivative of e to the 5x would be e to the 5x times 5. Okay, so kind of underderivative this, kind of write this as the derivative of y times the integrating factor, what we call mu. Then we're going to integrate both sides. You can't just start throwing around integrals. If you write this on a test, that's going to be -2. You can't write an integral symbol without writing a derivative. So I have to put a dx on both sides. Then the antiderivative of the derivative dx, these just cancel out, leaving y e to the 5x. And on the other side, the antiderivative of 0 was just my constant c. So we get y equals c e to the -5x. Let me pause a second. Something didn't go right here. Oh, I see. It was right here. When I was doing it as a separable, there's no x there. This was wrong. This was just antiderivative of -5 dx. So this would just be natural log absolute value of y equals -5x plus c. And then if we write that in explicit form, we'll get the same thing we got over here. Okay, let's do another one. Okay, so this guy, this one, by the way, is not separable. It's impossible to separate the variables here. There's my P of X. It's just this constant, -7. So my integrating factor will be e raised to the antiderivative of -7 dx. I'm going to do this all in one line in this one. This would be e to the -7x. Now, technically, there's a plus c here, but we're going to ignore that. For the integrating factor, never throw your plus c in. The plus c comes when we integrate the dE. Okay, we multiply everything by that. So e to the -7x, y prime minus 7y, e to the -7x equals e to the x times e to the -7x. Then the left-hand side, as long as I've done everything correctly, should be the product rule derivative of y times the integrating factor. Over here, I can just clean that up. That'll be e to the -6x. It's just rules of exponents. And you should check, do it on your own, check and make sure that if I take the product rule here of this guy, I do in fact get this left-hand side. And I do. Then I integrate both sides. Don't forget your dx on both sides. You have to physically write that in. It's a point off for every one of those you forget. Then the left side becomes just y e to the -7x. On the right side, we get e to the -6x over -6 plus c. Then let's write this in explicit form. Let's multiply both sides by e to the +7x. So that would give me just an e to the x over 6 plus c e to the -7x. Okay, let's do one that's a little more complicated. Okay, now, like I'm just going to get this one started and then I'm going to show you what could go wrong. So this is one you want to pay attention to. All right, so here's our p of x is x squared. So my integrating factor will be e raised to the antiderivative of x squared dx. Don't forget your dx. That's e to the x cubed over 3. Multiply both sides, everything by that. Then the left-hand side is the product rule derivative of y times the integrating factor. Notice how I'm writing out all the steps. Integrate both sides. Don't forget your dx or dt or whatever our variable is. Now the left side, that's easy. On the right side, I'm going to have to do a integration by substitution here. So if I let u, well, we already have a mu on the board here, and we might confuse ourselves. So maybe we'll call this w or v or something. Let that be x cubed over 3. Then dw will be 3x squared over 3d. Excuse me, dx, which is just x squared dx. So there's my dw. W dw is e to the w plus c. So then what was w? That was x cubed over 3 plus c. And then again, I could put that in explicit form if I wanted to by dividing by this guy here. The point I want to make here is this problem was set up to work out nicely by having this x squared there. If I had gotten something like this, if I had gotten on the right side this, we would have no way to do that. I don't even think integration by parts would help. Maybe might be able to do this one by integration by parts. Yeah, I think we could. But there are a lot of times you try to solve something as a linear DE, you get down to this step right here, and whatever you get right here is something you just cannot integrate. Remember, like this here has no closed form antiderivative. Like you can't do it. We can only solve that numerically. So just because something is linear doesn't mean we're going to be able to solve the DE. Now, anything in the homework is going to be set up. They pick stuff to put over here specifically so that you will be able to solve it. Okay, one more. I want to do an IVP. And I really like these ones where it's like a number over X. You're going to have a bunch of problems where it's something like this, maybe 5 over X, Y on the left-hand side. And you would think like that 5 would play very little role. That 5 is the most important number in the problem. These are always surprising. So the most important number here is going to be that 2. That 2 was very important. So my P of X is 2 over X. Then my integrating factor, mu of X, is e to the antiderivative of 2 over X dx. Antiderivative there is going to be 2 natural log the absolute value of X. Now I can't cancel this e and this ln yet. I got to bring this 2 in as an exponent. Now notice here, I'm dealing with a positive X, positive or non-negative Y. I can just assume here, I can take what's called the positive branch and assume X is positive and drop these absolute value bars. Or alternatively, when I bring in this 2, X squared is always positive anyways. In either case, I can drop those absolute value bars. So that's just rules of logs there. That 2 came in and became an exponent. Now, and only now, the e and the ln cancel out, and I get X squared as my integrating factor. If that had been, if we had had this equals whatever, then my integrating factor would have been X to the 5th. Work that out on your own and check that, see that. Okay, so I multiply everybody by X squared, both sides. And this is a required step. We're writing out complete solutions here. On the right, we'll get X cubed. Let's go ahead and cancel one of those guys out. We get X squared Y plus 2X, oh, X squared Y prime, 2xy equals X cubed. And then we should always check, and you got to write this down. This is a required step. If I take the product rule of Y times the integrating factor, do I get the left side? Derivative of Y is Y prime, leave the second alone, plus, leave the first alone, derivative of the second. That's right. Integrate both sides. Don't forget the dx. These just cancel out. The derivative and the antiderivative cancel out. Antiderivative of X cubed is X to the 4th over 4 plus C. That's where the plus C goes in. And now let's divide everybody by X squared. And we'll get, let's see, X squared plus 4, or X squared over 4 plus C over X squared. Now this is an IVP. Y of 1 equals 0. So we'll get 0 equals 1/4 plus C over 1. Yeah, I'm plugging in 1 for X 0 for y. So I think C is -1/4. So our particular solution looks like this. Now let's check that. Say this was a test question. Here's all the work. Pretty much everything you see here is all required for complete credit. Let's check it. That was y prime. I've already forgotten. Plus 2 over xy. Equals x squared. Equals x, and then y of 1 equals 0. So to put in the initial value condition, I just put a comma. Y of 1 equals 0. And there's my solution. It's the same thing I got. Now it looks a little different, like we'd have to simplify this a little bit and check, but it's the same solution. So to get credit on the test, you have to show all the work. And we're going to talk a minute about the test, but just to point it out one extra time, if you cheat on the test, you're absolutely getting an F in the course. Do not pay for any kind of solution. Don't use any outside help. You can use anything in the Canvas course, nothing outside. Don't cheat on my test. Okay, there was a couple of people wrote me questions asking about question 9 in, I think it was here. Yeah. So this question, I think I need to change the directions here, make this a little more clear. In each one of these, we're just solving for the highest order derivative and writing everything else on the other side. So like here, in this one, I'd be solving for that y prime right there. Okay, so I'm just trying to solve for y prime here. So I'm literally just dividing everybody by x. And then this function they're looking for is just this right side. So that f of xy that they're asking me to write out would just be this stuff. So look at here. If I look, see, that's what that is.